August 14, 1942, Detroit Tank Arsenal, Warren, Michigan. John Cars Caden, the plant manager, stood on the massive factory floor with a stopwatch, closely watching the build of hull number 217. The workers followed every step by the book, trained by Army ordnance experts. Each part was assembled exactly to spec. Every weld passed inspection, and every bolt was tightened just right. But there was a serious problem. Time. Hull 217 had already been on the floor for 11 days, and it would need another 8 to finish. That meant it took 19 days to complete just one M4 Sherman medium tank. At that pace, the plant, then the largest tank factory in the world, could only turn out about 420 tanks a year. The U.S. Army had ordered 10,000 tanks for 1943 alone. At the current rate, it would take 24 years to meet that one-year demand. Time and labor were working against them, but no one in charge seemed to see it. One man did. Charles Sorensen, a 47-year-old civilian and longtime production expert from Ford, was quietly running the numbers on the back of a supply form. With 36 years at Ford, he had helped revolutionize car manufacturing. Now, he was doing his own unofficial time and motion study on tank assembly, and what he saw didn't make sense. Tanks were being built like handcrafted machines. Crews move around a still hull to attach parts, a slow and outdated way of working. It was built for craftsmanship, not war production. Sorensen figured that by applying modern, continuous flow production techniques, he could cut build time from 19 days down to just 48 hours. Most people thought he was out of his mind. Army officials argued that tank production wasn't like building cars. The parts were too complex, the process too precise, and the materials too specialized. The current method, they said, was necessary, but Sorensen wasn't buying it. He believed in a different way, and he was about to prove it. What he brought to the table was a complete shift, using flow production for tanks. Within 18 months, his method would completely change how America built armored vehicles. The Detroit Tank Arsenal would be rolling out one fully assembled Sherman tank every hour, around the clock, 7 days a week. This is the story of how one civilian's bold approach helped turn American tank production into a full-scale machine, and how that momentum helped overwhelm the German army with sheer numbers. The urgency had actually started back in June 1941, 6 months before Pearl Harbor. U.S. military leaders saw how quickly German panzer units were tearing through Europe and realized American tanks were way behind. The M3 Lee, then the main U.S. tank, was already outdated. A better tank was needed, and fast. The result was the M4 Sherman, designed in just 78 days between April and June 1941. It was built with production in mind, not perfection. The engine, the Wright R975 radial, was already in use for airplanes. The 75mm main gun used standard ammo. The suspension borrowed proven parts. The hull was made for welding instead of complex casting to keep things simple. Even with a design made for easy production, early builds were painfully slow. Lima Locomotive Works in Ohio got the first contract in August 1941, but it took until February 1942, 6 months, to deliver their first tank. By April, they were managing just one tank a week. That clearly wasn't fast enough. So the government invested in a massive new plant, the Detroit Tank Arsenal, built on farmland in Warren, Michigan. Starting in September 1941, it was meant to be the biggest tank factory in the world. The main building covered 1.6 million square feet under one roof. The main assembly hall stretched 1,200 feet long and 600 feet wide. Chrysler, which had never made tanks before, was given the job of running the plant. They brought in their car-making know-how, but ran into resistance from Army advisors. The military insisted tanks needed to be built in a completely different way than cars, due to their complex armor, weapon systems, and heavy-duty parts. Despite that, the first Sherman tank rolled off the line on April 11, 1942, just 7 months after construction began. That first month, the plant produced 12 tanks. In May, output rose to 37. By June, they were up to 61 tanks. Progress was happening, but not fast enough. The Allies needed thousands of tanks each month, and Detroit wasn't even close. It wasn't a problem with the workers, the materials, or the equipment. The real issue was how the work was being done. Tanks were being built using old-school methods better suited for making custom locomotives, not modern military vehicles. Each tank stayed in one spot while teams moved around it, doing their part in order. This led to constant delays, workers waiting on tools, inspections, or for the previous step to be finished. In July 1942, Charles Sorensen arrived at the Detroit Tank Arsenal as a $1 a year consultant. His title didn't reflect his influence. Sorensen had been at Ford since 1906 and played a key role in turning it into the largest car maker in the world. He helped develop the moving assembly line that cut Model T production from 12 hours down to just 93 minutes. He had retired from Ford in 1941 after clashing with Edsel Ford, Henry Ford's son. But sitting out the war didn't feel right to Sorensen. He had come to the U.S. from Denmark as a child and saw American industry as part of his personal mission. When the War Production Board asked for help with tank manufacturing, he didn't hesitate. What he found at the arsenal confirmed his concerns. The tanks were being built with outdated methods, ones that hadn't changed since before Ford's assembly line in 1913. Instead of the product moving down a line, workers were still doing laps around the product. That small difference had a big impact on how slow things moved. For 2 weeks, Sorensen ran detailed time and motion studies. He took photos, talked to workers, and did the math. He found that making an M4 Sherman tank involved 173 separate steps. On average, each one took about 9.7 hours, totaling 456 hours spread across 19 days. But Sorensen saw something others missed. Most of those 19 days weren't spent working. They were spent waiting for the last step to finish, waiting for tools and parts, waiting for sign-offs, waiting for specialized crews to become available. His fix? Cut the waiting. Switch to continuous flow manufacturing. Instead of having workers go to the tanks would move past fixed stations. Each station would have everything it needed, tools, parts, and people ready to go. Each worker would focus on just one task, over and over, getting faster and better at it. Inspections would happen on the go, not at the end. In August 1942, Sorensen laid out his idea to Chrysler leadership and Army ordnance officials. The response? Doubt, and a lot of it. Brigadier General James Wesson, head of Army Ordnance, shot it down right away. Tanks weren't cars, he said, and they couldn't be built like cars. The components were too heavy, too complex, and required too much precision. Chrysler's engineers agreed. They raised a long list of technical problems. Tank hulls weighed 15 tons, too heavy for normal conveyor belts. The turrets had to be lifted in by overhead cranes, which couldn't work with a moving line. Some drivetrain parts weighed over a ton each. Welding the armored hulls needed the tanks to stay in one place, so the welds could set properly. But Sorensen had answers for all of it. Heavy-duty conveyors, like the ones used in train factories, could handle 15-ton tanks. Gantry cranes could be made mobile to move with the line. Heavy parts could be placed in advance at specific workstations using custom lifts. Welding could be done at stations where tanks paused just long enough to finish the job before moving on. The back and forth went on through August and September. Army officials still pushed back, saying their inspection rules didn't allow for this kind of system. Chrysler was nervous too. Redesigning the whole factory would be a massive task, and it could slow production down in the short term. Finally, Sorensen made a bold offer. He proposed a test run. One corner of the plant would be used to build 3 tanks using his new method, while the rest of the factory kept using the old way. If his team could build 3 tanks faster than 1 tank built the old-fashioned way, Chrysler and Army Ordnance would greenlight a full-scale rollout. The test kicked off on October 1st, 1942. Sorensen's team had just 3 weeks to set up a working mini-assembly line in Section D of the plant, an area previously used for subassembly work. It was a massive challenge. They needed custom conveyors strong enough for 15-ton loads. Tools had to be positioned for non-stop access. Components weighing up to 2,000 pounds needed their own handling systems. And the whole process had to be perfectly synchronized so that each step flowed smoothly into the next. To make his idea work, Sorensen brought in top experts from Ford's River Rouge plant, the most advanced factory in the country at the time. They engineered custom systems for the job: hydraulic lifts for heavy parts, reinforced roller conveyors, overhead tracks to deliver smaller tools and materials, and automated welding fixtures to hold the tank hulls perfectly in place. The prototype assembly line stretched 180 feet and included 11 main stations. Each one was built to complete its task in exactly 12 minutes. Station 1 brought in the basic hull components. Station 2 handled major welding using fixed guides. Station 3 added the internal structure. Station 4 installed the suspension and floor. Station 5 mounted the transmission and drive systems. Station 6 added the engine and cooling units. Station 7 wired up the electronics and controls. Station 8 brought in the turret and mounted it on the hull. Station 9 added tracks, fenders, and tools. Station 10 took care of final integration and filled all the fluids. Station 11 performed the final checks and operational tests. The first test run began on October 23, 1942, and it was a mess. The conveyors couldn't handle the weight of the tanks and kept jamming. The welding rigs weren't holding the parts in place correctly. Workers trained in the old ways struggled to adapt to these new, focused tasks. Timing between stations was all over the place. The result? Total chaos. Army observers watched it all and quickly called it failure. They pushed Sorensen to shut it down and go back to the old way. Chrysler's leadership agreed, concerned about the wasted time and materials. But Sorensen wouldn't back down. He had seen this happen before, back when the Model T assembly line first launched. Early problems didn't mean the system didn't work. They just meant it needed adjusting. He asked for 2 more weeks to fix the issues. Over the next 14 days, his team worked nonstop. Engineers reinforced conveyors so they could handle the weight. Welding fixtures were tweaked to match the real shape of the hulls instead of just relying on blueprints. Workers were retrained to focus on just one task at one station. Some tasks were split up or merged to balance out the workflow. The second trial began on November 9th. Things ran smoother, but not perfectly. Tanks moved through the line, but delays still popped up as new problems surfaced. It took 8 days to build 3 tanks. Not bad, but still far from Sorensen's target of 2 days. Then came the breakthrough. On November 16th, Sorensen tried something completely different, what he called the moving crew concept. Instead of having workers stay at fixed stations, small teams would now move with the tank, performing their tasks as it slowly rolled forward. This cut out handoff delays between stations while keeping the line in constant motion. The third and final test run started on November 23rd, during Thanksgiving week. Sorensen knew this was his last shot. If it failed, the Army would shut down the whole project and possibly push him out of tank production for good. But this time it worked, and it worked better than anyone expected. In just 41 hours, 3 fully built Sherman tanks rolled off the line. That's about 17 hours per tank, compared to 456 hours it used to take. A staggering 96.3% cut in build time. And the quality? Still top tier. Inspections found no defects. Every system passed its checks. The armor welds met strict military standards. The tanks were ready for battle. Army officials were stunned. Brigadier General Wesson, who had insisted this kind of production wasn't even possible, personally inspected the results. He found nothing to criticize and gave the green light to roll out Sorensen's system across the entire plant. The entire factory, over 1.6 million square feet, had to be restructured from the ground up. Old workstations were taken apart, new assembly lines were installed, workers needed retraining, and supply systems had to be redesigned. All of this had to happen without stopping the essential production needed for the war effort. To manage the transition smoothly, Sorensen split the plant into 4 separate assembly lines. Each line could run on its own, so if one had mechanical issues, the others could keep going. This also let some lines continue the old method, while others switched to the new system. Line A launched a continuous flow system on January 7, 1943. At first, Progress was slow, just one tank every 8 hours. But as the team got used to the new setup and worked out the kinks, that time dropped fast. By the end of January, Line A was rolling out 6 tanks a day, one every 4 hours. Line B switched over on February 15th, followed by Line C on March 1st. The last line, Line D, made the transition on March 22nd. By April 1st, all 4 lines were running, cranking out 24 tanks a day. That was up from just 3 per day 4 months earlier. Still, Sorensen wasn't done. His calculations showed that building a tank in just 1 hour was possible. The current 4-hour cycle was only part of the way there. He aimed to tighten every part of the process. The biggest holdup? Mounting the turret. It needed exact positioning and slowed everything down. So his team built a dedicated turret installation station. It used mechanically assisted arms, like early robotic tools, to lower the turret precisely onto the hull. The process took only 6 minutes and replaced a 30-minute delay. The engine was another challenge. The R975 radial engine weighed over 1,100 pounds and had to be lined up perfectly with the transmission and cooling systems. Sorensen solved this by designing a special motorized dolly that moved alongside the tank, letting the crew install the engine without stopping the line. Mounting the transmission and differential, some of the heaviest parts, was also tricky. Overhead cranes didn't work with a moving line. So Sorensen's team developed floor-mounted lifts that move with the tank, cutting down installation time significantly. These improvements rolled out across April and May 1943. By June 1st, they had the build time down to 90 minutes per tank. At the end of June, it dropped to 75 minutes. By July 31st, they hit 63 minutes, just under 1 hour per tank. The shift was complete. In April 1942, the plant made only 12 tanks using old methods. By July 1943, they produced 721 tanks in a single month, a 60x increase in just over a year. The numbers were astonishing. Traditional methods took 456 man-hours to build one tank. Continuous flow cut that to 48 man-hours. Labor efficiency rose by 950%. Factory space was used 4x more effectively thanks to better layout. Material handling improved by 600% with automated systems. Defect rates dropped 73%, even though the pace had increased. Workers became highly skilled at their specific tasks, boosting quality. And the impact went far beyond Detroit. Other factories quickly followed Sorensen's lead. Fisher Body's tank plant in Grand Blanc, Michigan, switched over in April 1943. Pacific Car and Foundry in Renton, Washington, made the change in May. Federal Machine and Welder in Warren, Ohio, began their transition in June. By the end of 1943, U.S. factories were building 2,100 Sherman tanks every month, up from just 200 a month in mid-1942. This wasn't because of more factories. It was almost entirely due to the new manufacturing method Sorensen pioneered. Germany didn't see it coming. Their military had estimated U.S. tank production at around 300 per month, based on traditional processes. When U.S. output shot past 2,000 per month, their planning collapsed. General Heinz Guderian, the top German tank commander, wrote in his diary in November 1943, "Reports suggest U.S. tank production has increased tenfold in 1 year. If true, this shows an industrial strength we cannot match. We can destroy tanks faster than they build them." That same December, Germany's Minister of Armaments, Albert Speer, gave Hitler the hard numbers, and the reality was starting to set in. At its peak, Germany was building around 540 tanks per month. Meanwhile, the U.S. was rolling out 2,100. That 4-1 advantage made it nearly impossible for Germany to win a long war. The strategic edge was massive. American tank units in Europe could keep fighting, knowing replacements were already on the way. Losing tanks didn't stop the momentum. It was a setback, not a crisis. For German forces, every loss hurt badly. For the U.S., losses were manageable. Even though the Sherman tank was often criticized for its thinner armor and smaller gun compared to the German Tiger or Panther, it didn't need to outgun them. It just needed to outnumber them. And it did, thanks to Sorensen's production system. That advantage came into focus during the Normandy campaign. From D-Day on June 6 to the end of August 1944, the U.S. landed 2,100 Sherman tanks in France. Germany destroyed about 800 in combat, but replacements kept coming faster than the losses. By September 1st, American tank strength in France was actually higher than it had been on D-Day. German panzer units couldn't keep up. Take the 2nd SS Panzer Division Das Reich. It arrived in Normandy with 89 tanks. Over 3 months of fighting, it didn't receive a single replacement. By September, they had just 14 tanks left. As a fighting force, they were finished. And this edge went beyond just raw numbers. Because Sherman production was so high, factories could produce different models without slowing down the main line. Variants like the M4 A3E8 with a 76mm gun, the M7 Priest artillery vehicle, the M10 tank destroyer, and the M32 recovery vehicle all used the same basic Sherman parts. That part standardization, made possible by Sorensen's mass production methods, made logistics easier across the board. But Sorensen's real contribution wasn't just new techniques. It was a shift in mindset. He showed that complex military hardware could be built with the same efficiency as consumer products. The Army Ordnance Corps, which had once resisted help from civilian manufacturers, ended up embracing these methods across the board. Artillery shell production adopted similar assembly lines. Monthly output jumped from 2 million rounds in early 1942 to 18 million by mid-1943. Aircraft engine production followed suit. Wright Aeronautical went from making 150 R975 engines per month to 1,500. Small arms ammo production hit levels no one thought possible. Lake City Army Ammunition Plant was producing for 1 million rounds per day using streamlined loading lines. All of it backed Sorensen's core belief. Complexity doesn't rule out efficiency. It just needs the right system. Break big. Complex builds into smaller, repeatable steps. Train workers to do one thing very well. Cut wasted time. Use specialized tools. Keep everything in sync. These principles, first proven on tank lines, became the backbone of modern manufacturing. After the war, industries from cars to electronics to construction equipment adopted these systems as standard. Sorensen didn't just change how the U.S. built tanks. He helped fast-forward the entire industrial world. There was also a human side to all of this. At its height, the Detroit tank arsenal employed about 40,000 people. With the old process, that workforce could maybe build 800 tanks a year. Under Sorensen's system, they produced over 8,000, a tenfold increase in productivity. But it wasn't about making people work harder. In fact, workers reported that the new system was less physically demanding. The key was eliminating wasted effort. No more hauling parts across the floor, searching for tools, or waiting around between tasks. Every movement counted. Each workstation was built for efficiency. At first, many workers resisted the change. But as the system improved, so did morale. People were being paid the same but doing less exhausting work. And there was a real sense of pride. Seeing a finished tank come off the line every hour, instead of once a week, gave workers a feeling of purpose. Even the unions, initially skeptical, came around. They saw the benefits, not just in output, but in working conditions. And beyond the factory, the impact was massive. Warren, Michigan, once a small rural town with 10,000 residents, became a booming industrial hub of 50,000 people in just 2 years. As tank production ramped up, so did everything around it. New housing, schools, hospitals, and roads were built to support the growing workforce. Other cities near tank plants using Sorensen's methods experienced the same kind of explosive growth. The greater Detroit area became known as an arsenal of democracy, a hub not just for tanks, but also for aircraft engines, military trucks, artillery shells, and countless other wartime materials. Still, it was a Sherman tank, rolling off those fast-moving lines, that stood as a symbol of American industrial power. What seemed impossible to German planners became reality in Detroit. Before we get into the legacy of this massive shift, now's a great time to subscribe and turn on notifications if you haven't yet. That way, You won't miss stories like this, where individual innovation helped change the course of history. Your support helps us keep these engineering triumphs from being forgotten. After the war, experts looked back and agreed Sorensen's impact on manufacturing was as critical as any new weapon. A 1948 report by the RAND Corporation on wartime industrial mobilization concluded that efficiency gains in production played a larger role in the Allied victory than any single military technology. And it called out tank production as the perfect example of what civilian industry could achieve when pushed to its limits. In November 1945, Charles Sorensen received the Medal for Merit, the highest civilian honor in the U.S. at the time. His award citation credited him with multiplying armored vehicle output tenfold and giving the Allies the material edge needed to win. Sorensen's influence didn't end with the war. In 1944, he became president of Willis Overland Motors and applied the same manufacturing methods to civilian Jeep production. Later, he helped companies worldwide adopt efficient production systems, spreading U.S. industrial know-how around the globe. In his 1956 autobiography, My 40 Years with Ford, Sorensen dedicated 3 full chapters to tank production, calling it the most meaningful work of his career, even more than building millions of Model Ts. He wrote, "Building Model Ts taught me how to manufacture. Building Sherman tanks showed me those lessons could help win a war. I'm proudest of the tanks, not because they were better machines, but because they made a bigger difference." His legacy lived on through Cold War and modern-era military production. The M48 Patton, the M60, and the M1 Abrams all benefited from assembly line techniques that grew out of Sorensen's World War II work. Even today, the Abrams tank is built on a synchronized line at the Lima Army Tank Plant, the modern successor of the original Sherman building facility in Lima, Ohio. The Abrams takes 2 weeks to build, much slower than the Sherman's 1-hour rollout, but that reflects its greater complexity, adjusted for the difference in design. Today's assembly process is just as efficient. The key takeaway from all this? Manufacturing speed matters. During the Cold War, U.S. military planners built strategies around one core idea. If conflict dragged on, American factories would outproduce the enemy. That belief, rooted in the World War II tank production experience, shaped everything from how forces were structured to how equipment was ordered and stored. And the Sherman tank itself? It proved the doubters wrong. Despite its flaws in armor and firepower, the Sherman had an incredibly long service life. It stayed in frontline use through the 1970s with several countries. The Israeli army used upgraded Shermans during the 1967 Six-Day War. Paraguay kept some in service until 1997, more than 50 years after they were built. This endurance showed that fast, large-scale production didn't mean low quality. When a design is solid and production line is tightly controlled, the results can match or even beat traditionally built equipment. The Sherman's reliability came from that consistency. Tanks built with identical specs and calibrated tools performed nearly the same in the field, tank after tank. And the economic side of the equation, just as important. In 1943, a Sherman cost around $50,000, roughly $800,000 in today's dollars. By comparison, Germany's Panther tanks cost about $140,000 then. The lower price of the Sherman didn't come from cutting corners. It came from Sorensen's efficient system. That cost advantage meant the U.S. could field more tanks faster. Tank destroyer units, armored cavalry, and even independent tank battalions were equipped with Shermans in numbers that would have been unaffordable with higher-cost vehicles. The Sherman tank became a fixture on every battlefield and in every role: frontline combat, convoy escorts, even guarding command posts, simply because the U.S. could afford to use it everywhere. The production numbers say it all. During World War II, the United States built 49,324 Sherman tanks. Germany produced 6,567 Panther tanks and just 1,347 Tigers, about 8,000 heavy and medium tanks in total. Meanwhile, the Soviet Union produced over 57,000 T-34 tanks using a similar mass production approach. On its own, American tank production was 6 times greater than Germany's. Combined with the Soviets, the Allies held a staggering 16 to one advantage in armored vehicle numbers. This dominance didn't come from having the best tank. German designs were arguably better in firepower and armor. The difference was in how the tanks were built. America's edge came from manufacturing. Sorensen's continuous flow system made it possible. It's hard to measure the human impact, but the effect was real. How many American lives were saved because fresh tanks kept arriving on time? How many battles were won because of overwhelming numbers rather than perfect tactics? How many German troops were forced to fight against endless waves of Shermans their own factories couldn't match? These questions don't have precise answers, but the overall impact is clear. Efficient production saved Allied lives and wore down the Axis. Germany never found a way to close the gap. Even with solid industrial capacity and skilled workers, they topped out at around 540 tanks a month in 1944, a decent figure, but nowhere close to what the U.S. was doing. It wasn't for lack of talent or tech. German engineering was top tier. The issue was how they built things. Their factories used small batch, craftsman-like techniques. Each tank was practically hand-fitted. Components needed tweaking. Finishing one tank took time and precision. The result was high-quality machines, but at a snail's pace. Germany never switched to continuous flow production, partly because of the complex designs, but mostly due to mindset. Their military procurement leaders believed custom work meant better quality and resisted standardization. That mindset sealed the difference. America's decision to simplify, standardize, and streamline gave a material advantage Germany simply couldn't counter. Sorensen showed that in a total war, having good enough equipment in huge numbers beat superior machines made in small quantities. This philosophy reshaped more than warfare. It changed how the modern world builds. Today's systems like continuous flow, lean manufacturing, just-in-time delivery, and synchronized assembly all have roots in the principles Sorensen applied during the war. Factories making cars, electronics, and everyday goods still rely on methods proven in tank production under pressure. Even Toyota's famed production system, developed in the 1950s, acknowledged its roots in American wartime manufacturing. Taiichi Ohno, the system's creator, studied Ford's methods and closely analyzed U.S. tank production. Concepts like Kanban, synchronized workflow, and continuous improvement reflect the ideas Sorensen brought to life at the Detroit Tank Arsenal. Today, these lessons are taught in business schools and manufacturing programs around the world. Tank production during World War II is still used as a model for rapid industrial transformation. Students learn how to find bottlenecks, reduce wasted time, sync up processes, and design efficient, specialized workflows, all based on Sorensen's approach. The story of Charles Sorensen and the Sherman tank isn't just about war. It's about an American way of solving big problems with organization systems and smart execution. While other nations focused on battlefield tactics or cutting-edge designs, the U.S. focused on making more and doing it smarter. This wasn't a case of choosing quantity over quality. It was about understanding that having enough of the right equipment, delivered on time, is a quality of its own. A Sherman may not have outclassed a Tiger one-on-one, but a dozen Shermans on the field made the point clear. Going from 19 days to build a tank down to just 60 minutes wasn't luck. It was one of the greatest manufacturing breakthroughs in history, a 96.3% reduction in time without cutting corners on quality. And Sorensen's so-called impossible trick? It turns out it wasn't impossible at all. It just took vision, precision, and the courage to rethink everything. All it took was someone willing to question the norm, someone who could spot waste, understood what needed to change, and had the reputation to actually make it happen. Charles Sorensen had all three. His deep manufacturing experience as Henry Ford's right-hand man gave him the knowledge and credibility. His commitment to helping win the war gave him the drive to push through the resistance. Army ordnance officials who first dismissed him eventually became supporters. Even Brigadier General James Wesson, who once said continuous flow tank production was impossible, changed his view. In his 1946 memoir, he wrote, Charles Sorensen taught the Army that military urgency doesn't justify manufacturing inefficiency. He proved precision and speed can go hand in hand. We should have listened to him from the start. Chrysler, a company that had never built a tank before the war, and had pushed back on Sorensen's methods early on, became the world's top tank manufacturer. By the end of the war, they had produced 25,000 tanks, more than any other facility. After the war, Chrysler's Defense Division remained a key military contractor. They went on to build M48 and M60 tanks, using modernized versions of the same continuous flow principles Sorensen introduced. The Detroit tank arsenal kept operating through the Cold War, supplying tanks for every American conflict up to Operation Desert Storm. The last tank rolled off the line in 1996, 54 years after the first Sherman. Eventually, the massive factory building, over 1.6 million square feet, was demolished, but photos from its peak still show lines and layouts that clearly evolved from Sorensen's original system. And the people who worked there, many of them women stepping into factory jobs for the first time, showed the world what organized production could do. Rosie the Riveter became the face of wartime industry, but the truth went even deeper. Millions of Americans with no prior experience learned to build tanks, planes, ships, and weapons with efficiency that stunned even seasoned manufacturers. This shift was revolutionary. Before the war, manufacturing relied heavily on skilled craftsmen whose abilities took years to develop. Sorensen's system changed that. By breaking complex tasks into smaller, repeatable steps, almost anyone could become productive in weeks, not years. The social impact was just as meaningful. Women, Black Americans, and other groups previously shut out of skilled industrial jobs found new opportunities. Discrimination still existed, but the demand for labor opened doors that peacetime had kept locked. Wartime proved what these workers could do, and those changes began to chip away at long-standing barriers. The economic ripple effects were nationwide. Communities like Warren, Michigan, grew from small towns into thriving industrial cities. Tank production created jobs, brought new infrastructure, and left behind a strong industrial base that supported the economic boom of the post-war era. The same workers who built Shermans later built the cars, appliances, and consumer goods that defined American prosperity in the 1950s and beyond. Charles Sorensen passed away in 1968 at the age of 87. He lived long enough to see his methods become global best practices. His New York Times obituary called him the man who taught America how to build tanks. But his impact went far beyond armored vehicles. He changed the way the world builds. His personal papers, now held by the Detroit Public Library, contain the blueprints of that transformation. Engineering diagrams, production timelines, time motion studies, and correspondence. Together, they tell the story of how one man's experience and vision reshaped military manufacturing forever. Researchers studying industrial history and the evolution of modern manufacturing still turn to Charles Sorensen's archive papers. They see them as vital records, first-hand documentation of a turning point in how we build things at scale. And while the 96% reduction in tank assembly time is impressive on its own, the real measure of Sorensen's impact was strategic. Between 1942 and 1945, U.S. factories built more tanks than all other nations in the war combined. That production power gave the Allies a critical advantage in both Europe and the Pacific. Every Sherman tank that stormed a beach, rolled through hedgerows, punched through German lines, and advanced toward Berlin carried with it the unseen force of American manufacturing. Behind every tank crew, every infantry unit they supported, and every civilian they helped liberate was Sorensen's system. German troops learned quickly that knocking out a Sherman often meant facing three more. No matter how advanced their tanks were, no matter how skilled their crews or tactically sharp their generals, it wasn't enough. America could absorb losses and keep moving forward. The German army couldn't. Sorensen's so-called impossible trick, cutting tank production time by more than 90%, wasn't just about speed. It was about converting industrial capacity into battlefield dominance. It showed that capitalism and democratic organization could not only compete with authoritarian regimes, but outproduce them decisively. It proved that American innovation, when applied to manufacturing, could deliver results no one else believed possible. Cutting tank construction time from 19 days to just 1 hour wasn't a gimmick. It was a symbol of what focused expertise and relentless determination can achieve. Sorensen, a single civilian with deep knowledge and a clear vision, reshaped the entire concept of military production. His work didn't just win a war, it set the foundation for modern industry. The Sherman tank may not have been the most advanced design of the war, but it was reliable, easy to maintain, and, thanks to Sorensen, available in overwhelming numbers. That combination of good enough quality and unstoppable quantity became the formula that broke the back of the German war machine. It was a winning formula of industrial warfare, and Sorensen perfected it on the factory floor of the Detroit tank arsenal. Even now, when experts talk about continuous flow, lean systems, or synchronized production lines, they're building on lessons learned during Sherman tank production. When today's military planners evaluate mobilization capabilities, they still reference the model Sorensen helped create. And when historians ask how the Allies actually won World War II, more and more of them are pointing to the sheer scale of output, material superiority made possible by American manufacturing. Which means Charles Sorensen's name belongs right alongside the great generals and scientists of the era. His battlefield was a production floor. His tools were not weapons, but conveyors, cranes, and precision fixtures. His victories weren't measured in miles of territory, but in tanks per hour, and they were just as important. Charles Sorensen was a man who made the impossible real. He taught America how to win with numbers, discipline, and engineering. He showed that sometimes the most decisive advances in wartime don't come from breakthroughs on the front lines, but from breakthroughs on the assembly line. His legacy? One of the most important military innovations of the 20th century, built not in combat, but in a factory. Charles Sorensen's impossible trick changed the world, and it all started with one man deciding that 19 days was too long to build a tank.